Good morning. Today we are going to see the concept of cables, and then we are going to solve university exam problems. So now cables, we have in this system of cables, or if we will say wires, in this we have always tension. Cables are not going to resist any compression. So cable can sustain tension only. That is the most important part we have to keep in mind. So whenever we will consider any cable, we have to show tension in it. Means from both end, your arrows should be away, because we know tension means arrows should be away from the joint. So now we can have this cable. So already I mentioned cables are always in tension. So we have this is cable system. At B you can see some force is applied, and at C some mass is attached, and from that mass we are going to find out weight of that block. Now the important in this, we can apply all three equilibrium equations to analyze these cables. We have summation fx0, then we have summation fy0, and then we have moment about any point 0. Now here we have moment about any point 0. Now in this we can consider joint A separately. We can find the values. We can consider joint B. So we can show like this. We have, these are the values. We can say this is F. Then we know we have tension. So we have TBA. And then we have here, that is TBC. We can consider any section. So I can consider only this part, or I can consider this part. Means I can say we can consider this. So we have like this. So we can consider this portion also. We can take section from any cable, but we are not allowed to take section from joint. Means I cannot take section like this from joint B. That is not allowed. So you have to take section through the cables. So you can take from anywhere, and you can apply these equilibrium equations, and you are in position to find the values. Now we have cables are always in tension. Then steps to be followed. Generally, following steps are preferred. So we have considered joint with two unknowns. So any joint we have to consider, and there should be two unknowns. Why? Because whenever we will consider a joint, we have this as a concurrent force system. Any joint is concurrent force system. And whenever we have concurrent force system, we have only two equilibrium equations, summation fx0, summation fy0. We cannot apply moment 0, because concurrent force system means forces are acting at a joint. And therefore, we can't use moment equation, because all forces are passing through same joint. So we have, this will be first, and second we have, if the joint with two unknowns is not present, then determine reactions. So do not go every time with reaction and then other values. Prefer first one. But if reactions are asked in the examination, then we have to go with that only. If reactions are asked, in examination, then we have to go directly with reactions only. So now we will solve two university exam problems. So we have first, three cable segments support the loading system as shown in figure. Determine the support reaction and maximum tension in segment cable. So now where we will get maximum moment, maximum tension, maybe in this cable or maybe in this cable. Now, which cable we will get? So if I will say we have this as theta1 and we have this as theta2. We know as no horizontal force is acting on the cable, So whatever value of HA over here, we have same value of HB only in opposite direction. So I can say magnitude of HA should be equal to magnitude of HB. So if I will consider joint A, then what I will get? We will have this as H. Now I will say HA equal to H, HB equal to also H. So we have H, then we have this will be tension. T1 I will say. And then we have this angle as theta 1. And we have this will be my reaction, VA. Now, if I will write summation fx 0, then I have minus H plus T1 cos theta 1, that is equal to 0. And from this we will get T1 that is equal to H upon cos theta. And then if we will go in the same way over here, then we have this will be H, this will be VB, and this will be T2. Then we have this will be theta 2. Now I will not write reaction, but we will get T2 that is equal to H upon cos theta 2. Now, we have to see if theta 1 is less, then we have T1 greater. If theta 2 is less, we have T2 is greater. Means we have to see theta 1 cos theta 1 is greater or cos theta 2 is greater. Now, which one will be greater? So if we have theta 1 is less than theta 2. So you can see, I will mention, let us, I will write cos 45. What will be my value? 0.707. Now I will write cos 60. So we have 0.5. Means if your angle increases, your value of cos decreases. And value cos angle increases, cos value decreases, and you have denominator value in cos. So if theta 1 is less than theta 2, you can see over here, then we have T1 greater than T2. Because if theta 1 is less, so this you can see, sorry, then we have, if theta 1 less than, so we have this value, and then we have T1 also less than T2. Because if theta 1 is less, then we have cos 45 is less than cos 60. So here I can say cos theta 1 less than cos theta 2. So cos theta 1 is greater than, cos theta 1. If theta 1 we have less, then my value of cos theta 1 is greater. If theta is greater, you can see over here, then cos theta 2 is lesser. So as cos theta 2 is lesser, then I have T2 is greater. And as cos theta 1 is greater, then we have T1 is lesser. So denominator is less, numerator will be greater. If denominator is greater, numerator will be less. So always keep in mind, whichever theta is greater, your tension on that side will be larger one. That we have to keep in mind. So now we have, this will be my FBD of cable. Now we will directly find reactions, because now you can see we have this will be at same level. And as it is at same level, HB passes to HA, and we are going to get, or HA and HB passes through A. So we can take moment about A, we will get value of VB. So I have just taken moment about A0. So we have this will be 500 into 3 clockwise, so plus 400 into 10, and due to VB we have minus VB into 14 equal to 0, and we will get VB 392.86 Newton. So we have this will be value of VB 392.86 Newton. Then we will simply apply Fy0. We have Va, then minus 50 downward, minus 400 downward, plus Vb, and that is equal to 0. And then we can find value of Vb. We will get this value of Vb, that is equal to 507.14 Newton. So 507.14 Newton. Now, knowing this value, we can consider joint A, because at joint A we have known HA, and then we have unknown, that is HA and TAB. And therefore, we have considered this joint, because as we know this as 3 meter and this is given as 4 meter. We cannot take joint B because we do not know this distance. So we cannot find this. Here we have 3 unknowns. We have theta unknown. We have tension TBC unknown. TBD. So AB. So let us, we have C and D. So we have TBD unknown and HB unknown. But at A we have only 2 unknown. So we can use this and we can write summation Fy0, from which we will get TAB by 7.14 minus TAB sine 53.13 vertical, so sine angle is with horizontal, and TAB we will get tension in cable AB 633.93 Newton. Now once I know TAB 633.93, so 633.93 Newton, then we can find value of H. Simply use Fx0 TAB cos 53.13 minus HA equal to 0. And from this we will get HA 380.36 Newtons, because TAB we know 633.93 Newton. Then knowing this, so now whatever value of HA we have, same value we have for HB 380.36. So this value is also 380.36. Now we can have summation Fx0. So just I have mentioned this. Now T, this is C. So okay, C or D, you can see it. So if I will say this is C, because not mentioned, here I have taken this as C. So here also we have to mention it as C. So this will be TBC. This point is C letters. This point we have D point. So now we can have this. So we can simply use root of, because if we will consider this, then we are going to be in this fashion. So this becomes your resultant. So we have this will be in this direction. Then we can take this as root of 380.36 plus 392.86 whole square, and TBC is 546.82. Now you can see, so as our value that is of TBC is 546.82, that means definitely we should have this angle. If I will say theta, then this angle theta should be less than, we have this as 53.13. So this angle theta should be less than 53.13. You can check it now. If we have, this will be 546.82 and HA we have 380.36. And this angle we have theta. So if I will write it as cos theta, that is equal to 380.36 divided by 546.82. And we will get this angle 380.36, 546.82, shift cos inverse 45.93. Already mentioned, this should be less than, then only we will get tension in this cable greater one, because that tension we have 633.93. So automatically we should have this angle, well, this angle that should be greater than this angle. So likewise we have to solve the problem. Then we will go with one problem. This was also asked in examination, and we have to find value of P and we have to find value of A. Now reactions are not asked. So we will check which joint we can go for. So you can see this. If I will go to joint B, then we have here tension is unknown. Here we have tension unknown. Then we have this angle unknown. This angle we can find. So how we will get this angle? So we can have actually this distance 3. This will be 6. So we can have 3 by 6. And that angle we will get it as 26.57. So as at this joint B, we have 3 unknowns we cannot solve. We will go to joint C. Then we have this will be tension. Then this angle we know, which we have already calculated, 26.57. So one unknown tension and other P. So we can take joint C and solve the value for P. So we can go for this. So this is pre-body diagram. So we have considered joint C. Let that will be TCB. Angle we have 26.57. We will apply summation Fy0 and then we will get it as minus 735.75, which will be this weight, and then plus TCB sine 26.57, and that is equal to 0, gives me value of TCB 1644.9 Newton. Then I can go summation Fx0, and from this I will get value of P, that is minus 1644.9 cos 26.57, because now this value we have 1644.9 plus P equal to 0, and we will get value of P that is equal to 1471.18. Now we have to find value of A. Then you can consider joint B, or you can take moment about A. So I will prefer moment about A0. So we can have 735.75, which is value over here, 735.75 into this distance, 6 plus A. Then we have plus 637. So we have this will be 637.65 into A minus 1471.18 into 7. Now we have this force is horizontal. We have to consider this vertical distance, which will be 4 plus 3 equal to 7. And then equal to 0. And if we solve this, then by solving this, we will get value of A 4.28 meter. So reactions are not required over here. So that you have to see. If reactions are not asked, then can we solve without calculating reaction? You have to check it. So likewise, we have to solve the problems of cables. Now we will stop here only. Thank you.